Hello everyone, let's go ahead and work on making a bottle that has a consistent thickness even through all these, crazy features that we have. And I'll cut this in half so you can see that it really is constant thickness, and it really is, the bottle that we think that it is. And I've got another version of this that's more of like a detergent bottle. This is cut in half. It has, the insert that a laundry detergent bottle would have, and the threads and everything. So these should be kind of handy if you're looking to make bottles or something similar. And I'll throw this up on GrabCAD so you can access two examples of these online, and then I'll create a new part here. So we've got this new part. Let's go ahead and make a bottle. But before we do, and speaking of getting things online, let's talk about today's sponsor, Brilliant, where you can get knowledge online. If you'd like to get models off the web, I suggest GrabCAD. But if you'd prefer to get knowledge off the web, I suggest Brilliant.org. Whether you are someone looking to sharpen your skills you learned long ago, a casual learner that wants to learn more from the world, or a new professional interested in growing and monetizing your skills, Brilliant.org is a great place to start. Alibre has a Python console and uses Python scripting to make interesting objects like Mobius loops. If you have goals to automate all kinds of things in Alibre and other platforms, the Python course on Brilliant.org can help. With new content always being added and thousands of lessons from algebra to cryptocurrency, there is something for everyone on Brilliant.org, where large, complicated concepts are broken down into simpler ones. One of my favorite features is the visual learning. I bet you wish your water boiled that fast too. It doesn't take a lot. 15 minutes a day will really add up and supercharge your skills. This is a great way to join those who shape the future. Please use the link in the description below to get started free. Brilliant.org/jokoengineeringhelp. The first 200 who sign up will receive 20% off a premium subscription. All right, so we'll get started with creating a sketch. Let's do so in the XY plane. I've got no reservations about putting my origin right here at the bottom corner, right? So I have like my big vertical, big horizontal, and then we'll sketch out kind of a bottle shape with tangent arcs here. So go tangent arc, tangent arc, tangent arc. We'll make sure that this line here is horizontal, and then I can grab a vertical where this point and this point are vertical so that it's smooth all the way through. Make sure that this arc and this arc here are equal, and we'll give this arc a radius of, say, 2 inches. That changes our dimensions on everything else just a little bit. So we'll make this, say, 10 by 14. And we'll bring this guy up. Well, that's a good way to dimension things. Maybe this arc center here will be just below the top by 0.15 there. And then from here to here, maybe we'll say 9.650. And then maybe we'll make this line 3.5. And again, when you make a line, it is generally best practice to select both endpoints of the line rather than just clicking the line, but this works. So we're going to say deactivate. We're going to do the sketch here. We're going to say mid-plane, and we'll make sure that this is something like a distance of 6. Then we'll jump into our XY plane here, and I'll start by projecting a reference figure of, in fact, I could do the whole face. I don't see a problem with that. Maintain association. Make a line here and another line here. Now make sure that they're equal, right? So these are the start and end points of the handle of the bottle. And then I'll go with this kind of arc, and I'll set it to be tangent to this other arc. Apparently that already exists, which I've got no issue with. Jumping into my tangent arc. I'll select a valid endpoint. Right there. And we'll make a line and make sure that we have a tangent relationship between our arc and our line. I'll give this a dimension radius. Right, so we've given this arc a radius of 5. Next, going back to the tangent arc here, do an arc there, and an arc there, like that. And then let's go equal from here to here. Also equal from here to there. I'm going to choose a center point arc now. There to there. I'm going to move this guy down a little bit. And then go back to our arc and go from there to there. And we'll make sure that we have a tangent relation, just like that. We'll draw it and make sure that we have our parallel autorelation go in, adding a tangent there to there. Almost done now. There to there, and that looks like the center point of our arc. There to there. Yeah, unable to determine a solution, that's fine. We'll do it some other way. We'll grab a horizontal from there to that point. Yeah, maybe I'm not on the correct arc center, so let me just redraw that. I thought I was on the right one, but that's fine, right? I'll do that kind of arc, and then we'll go tangent and tangent. I can also further make sure that I'm concentric there, which is my design intent. So where am I not constrained, right? I want to constrain all this stuff. We're going to say, how about from here to here, distance of 1.625. And then from here to this arc endpoint, there we go. We're going to say 1.75. All right, where else are we not fully constrained? If I simply click and drag, I'll want to make sure that this line is a distance of 1 inch. And we're getting there. We've got some black in the sketch. I'll hit Control Z to reposition that. Next, I'll just make sure that this has a radius of, let's go with 1. And we're fully constrained. That's what we want. So we're going to deactivate the sketch. Let's extrude this, and I'm going to go with mid-plane, a distance of 2.25. And we've got that starting to look like a bottle. Now, any astute viewer is going to look at this and say, well, there's an issue here, and that is when we go to fill up the bottle, we'll get a little air trap in there. So that's a very valid concern, right? You're the engineer on this, and if you have a concern like that, then go ahead and redesign it so that it's to your liking. This isn't a very serious design for me because I'm not actually manufacturing bottles. I'm doing this for fun, and I kind of like the look of a raised handle, even if it has a little problem in there. So maybe you want an air bubble in there because if the liquid in there freezes, it gives it some expansion room to freeze, right? I mean, there's all kinds of pros and cons to every design, and it's your job to decide what pros and cons are best for you. So I'm putting that in your hands, but this is what I'm going with for the purposes of this video. I'm going to select this face now, and we will add a circle. Make sure that we have a horizontal constraint. We'll give the circle a diameter of 3, and we'll give from here to here a distance of 1.75. We'll deactivate that sketch. We'll extrude it up to 1 inch, right? So that's where we fill and put the cap on. And then let's do a little bit more of a complicated sketch. Let me select this face and sketch on it. We'll select the face again. We'll import this whole border of this face as a reference figure. We'll highlight everything. And then we're going to say offset. And actually, you know what? A distance of 0.7 is pretty good. So let's offset that a distance of 0.7. And you may want to use constraints and relations to make sure that this sketch really is fixed. So I'm going to just add 0.7 all the way around now. Again, with design intent, right, you want to avoid using repeat dimensions if possible. So there are better ways to define a sketch than by simply adding the same dimension over and over. Right, where we're not constrained, we want to make sure that we're tangent everywhere. But for the purposes of speed in this video and this not being that serious, then I am content with not having the best design intent in the world for this specific item. I guess that's the part that's not constraining it. So we're just going to add a concentric. Yeah, you can tell it's not concentric. And we're fully defined. So that's what we want. You can also, right, click on a point and use this lock to lock it down if you don't want to use constraints and relations, all kinds of things to get to this same point. Let me highlight everything. I want to make sure that everything is referenced the more that I think about it. Let's add an X shape on the side, and this X shape will do a pretty good job of bracing up the side to be stronger. Kind of like the way an I-beam is strong. So we'll grab a distance here. We're going to say 3 inches. And then we're going to go to 100 there. We're going to go to there. And I'm going to make sure that this is centered. So I'm going to grab a line, grab the center point of my line, go up here and make sure that this line is vertical. And that way I know that I'm going to be centered no matter what I do. We're going to go here, and maybe I'll just stick it to this arc somewhere. Good. So we've got our 100-degree angle, and I'm going to work off that. Let's go with collinear. Of course, things change rather dramatically. Oh, come on. Let me do this kind of sketch work. Again, I'll add 3 again. That's a repeat dimension. And, you know, when you go to update these sketches, you can run into some problems if you have a whole bunch of repeat dimensions where you have to update like 3 here and then 3 there and 3 there. So, you know, you can use equal relations and other things if you're serious, so that you adjust 3, and then everything that's a dimension of 3 will update if you need to change the sketch later on. That's up to you. We'll add a collinear there. Collinear. Collinear. So we've got that pattern cut out. Now I'll add a line. And we're going to make a sketch there. And I hear my 3-year-old crying, so I'm going to pause the recording for a second. And I'm back. So both my kids have foot, hand, and mouth right now, and it is kind of miserable. Let's go with there to there. I'll make an arc. And sometimes these arcs can be a little bit stubborn, but I think when you click on a point, yeah, you know what, let's trim that. Right there, right, perfect. So trim that so we have an enclosed section there. We want to enclose this section. When we select a point that's on the arc for our 3rd point, then it works. It won't be defined if I select a random point because, right, this point needs to get defined. Hey, what is this? That shouldn't be the case. So let's make sure that we are concentric, unable to determine a solution. This looks like maybe if there we go, that defined it. Okay, the world is right again. That really rocked me for a second. Just need another constraint right there. So you can also just put it to a different size and make it equal, and then that arc is fully defined right there. All right, we'll go with another line there. And I think we've enclosed here, 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 and there, and it looks right. So we can deactivate the sketch, moment of truth, and it looks like it's working. Negative 0.25 is what I want. Let's do a mirror, and we'll mirror this cut across this plane, and we'll say OK. There it is. So we've got this sort of X shape that helps to brace up the side of the bottle a little bit. So what do we want to do? I'm going to add some fillets. Now, I'm not done adding features, and you definitely want to keep adding features and add fillets and chamfers at the end. But I have some features that are going to interact with my fillets that I'm going to add. So I'm going to make an exception here and add some fillets, just enough to get a complete amount of fillets in the area that I'm going to continue adding features, and then we should be good. So I'm going to add first a fillet. Then I'll make 0.7. That was the offset distance we made on some of these features on this face. And I'm going to do here. And yep, that works. There. Might as well continue going around here. You can hear my daughter crying through the microphone. She's taking her medicine with Mom. And medicine is not fun to give to kids. I'm sure I've got people who have kids that are watching this, so back me up in the comments. It's really something. We are going to add a rectangle. We'll go with there to there. Right, symmetric. All right, then I'll select this face. We'll project with maintain association, reference figure. So I can just measure off of these lines. We're going to say 0.5. Obviously, if you're doing an engineering drawing, you wouldn't want to measure off of this tangent point. It'd be a nightmare. 0.5. Again, you can use symmetric if you want to reduce the number of 0.5s. 0.5, there we go. We'll deactivate, we'll cut in 0.25. So I used, oh, I don't know if that happened, so I'm going to say negative 0.25, and then there's our cut in, right? Okay, so we dimensioned this cut from the tangent lines of these fillets, which isn't like the best way to do things, right? You'd want to do it from some other face that's a lot easier to measure, but that just gave me enough clearance to say, okay, I know I'm ½ inch away from the nearest part of curvature. So you can model that way. You just don't want to dimension it that way in a drawing, because that would get a lot of people mad at you. But let's go with adding some grippy features up here that I think you really should have some fillets already done on to demonstrate what it's going to look like when it's all filleted. So let's add some fillets here. I'm going to make sure that this is a fillet of 1, 1, 1. Right, this is starting to look a little bit more curvy like the bottle should. So all those are added. And then I'm going to go with 0.5. And we'll add here 0.5. And then make sure that we choose the correct edge, 0.5. We apply that. And then maybe, yeah, you know what, 0.5 is good. We'll go 0.5, 0.5. So now we've made what looks a lot more like a real bottle's handle. Close that. Again, I do warn you have an air trap up here. So you're the engineer, you get to decide, you know, if you want that or not. Let's work on some grippy features. And this will be, I think, pretty fun to add. Let's choose this bottom face first. And then I'll reset my view, so I'm looking up on there. I've got my origin right here, kind of at the base of my handle. So I'm going to add a circle. We're going to give that circle to be something like 0.25. We'll go from there to there, a horizontal dimension of 0.95. And then we'll go vertical dimension relative to the origin, say 1.5. There we are. We'll deactivate the sketch. Let's select this top face and we'll make yet another sketch, and we'll again give this a diameter of 0.25. Give this a horizontal dimension, and we'll go with 0.95 again. Actually, instead of 0.95, I'll go with 1.32. Perfect. And then vertically, we'll say 1.56. All right, we'll deactivate the sketch. We'll go with the subtractive loft from here to there. And there we've got a grippy cut into our feature. So let's go with linear patterning that. And what I'll do, we'll select linear pattern. It already has our loft selected. We'll choose our path to be here. Our spacing will be something like 0.5. And instances, let's go with 7. We've got this grippy pattern, cutting the side of the handle. That should make it a little bit easier to grab. We'll mirror that, and not only mirror that pattern, but we'll also mirror the seed of that pattern. So we have the grippy pattern on the other side. And then I think we're ready to do some filleting. Again, we'll save our fillets for as late as possible. I did want to have this fully filleted to give an idea of what this handle is going to look like when it's all done. I think that that's fine to do a few fillets early, and then the rest of our fillets we'll do now. I'm going to choose all these little internal corners of my X shape. That's what I wanted there. So we've done this side. We'll do this side now. It's important, right? All these little fillets are important because when we go to make this hollow, you want to be very aware of what your smallest radius of curvature is. And that's why it can help to not use splines and to not use lofting if you don't have to, because sometimes splines and lofting can produce very small curvatures that will make it impossible to hollow out at the thickness that you wish. And by using fillets and these kinds of features, we have set radii that we adhere to, so we can always say this is the minimum radius of curvature of this part. So I know that 0.25 is going to be the smallest radius that I can make something, that I've made something with. All right, I'm trying to do too many things mentally all at the same time here. You know, keep track of talking about what I'm going to do in the future while I'm doing something in the present. It gets a little bit hard to talk and think at the same time that way with, but there we go. I think we have all of these fillets good. Now I'll add this face. Right, a lot easier than clicking edges. We'll apply that, and then apply secondary fillets around here, and I can select these straight edges as well. Good. All right, so we've got those fillets worked out. Wow, we are well on our way here. Next, if we so wish, we can select these sharper edges and just smooth them out. Because it's not that realistic to have, you know, oh, I can even select the faces. It's not that realistic to have sharp edges on a bottle like this, so those smooth edges might really help out. Okay. Then I think the very last sharp edge that we have is going to be this guy. Make that even bigger at 0.25. And then comes the fun part. Why don't we hollow this out now? I select my top face because that's where I want my opening to be. And I choose shell. So now I go to add a shell, right? I'm shelling at 0.1 and I got this little salmon error button. And that's a problem, right? Because I can't add a shell at 0.1. So I go to cancel that. And then I look at these features and look, my minimum radius of curvature is at 0.1. So if I make this something like 0.15, let's see if that works. Okay, so it likes 0.15. Let me see if I can get up to 0.2. Nope. 0.175 it is, right? So now that I've increased my minimum radius of curvature, I'll highlight this top here, and we're going to go to shell. And now it works at 0.1, no problem. So we were able to find and correct something that would have otherwise been a problem if we wanted to shell at 0.1. And this is kind of what a good designer will go through in understanding the minimum radius of curvature, which in this case is 0.175, as it relates to shell. So I can make this maybe 0.15 and I'll still be okay. And we've thickened up to 0.15, no problem. If I go to 0.175, we'll break, right? Well, 0.175, and we break. So that is why it's so important to know the minimum radius of curvature when we are shelling things. The smallest radius we have on here is 0.175. I want 0.1, so I'm going to add my 0.1 shell, and there we are. We are now hollow. If we wish to add a thread on the bottle, you of course can use thread tools or whatever. I like to actually model out my threads because it's often because I'm 3D printing them, right? I have 3D printed threaded features right here on my desk that I had to model in. So just for the sake of example, let me model in a thread. And I know I'm going to do a custom thread on this. A lot of plastic threads are custom threads because, hey, you're making injection mold tooling anyway. Why try to make it match up to any standards? Let's go with a 60-degree angle. That's a pretty standard thread size, I think. And then, yeah, I think that forces it to be an equilateral triangle. If I remember my geometry, I might not. Let's go here and say, what do you think? 0.25, reasonable size for that kind of thread. Let me project, right? There's a few ways to find the center of this. I think the best way would be to add an axis to this face, but I think creating meant for that to be a reference works too. I'll add a line here, reset my view. So I've added that line just so that I can see a sample of what this part axis is going to look like. All right, make that 0.01, right, just above, and then I'll trim off the excess. So I'll deactivate the sketch. We'll go with the helix feature. We chose our reference line. We want a height of, let's try 1 inch reversed. Yeah, that's not bad for height. Let's tighten up the pitch. Maybe let's go with 0.5 and see if that's too tight. No, I think that works for me. All right, so that'll be our helix there. We'll activate a sketch and trim off the top. Okay, I'm glad I didn't hit that handle. Again, best practice, fully constrain that, right? But I'm going in the interest of time. I don't think everybody needs to see me fully constrain every little thing to understand the concept of what I'm doing. So I'm going to get away with being naughty just these few times. Let's go with the fillet. I'm going to say 0.02. Let's see where that puts us. Doesn't like that. Oh yeah, we got plenty. 0.1. Bit too tall. It's a custom thread though, so right, it's whatever you want. That worked. And there, right? So then you can make a bottle with the same, bottle cap rather, with the same thread pitch and pattern and everything. This guy, maybe I can take the easy way out and just fill it around here to give it sort of a finished look. All right, so that is an approximate bottle. There's some more finishing touches that you could probably put on it. Oh, that makes for kind of a nice thread start, doesn't it? And then, yeah, I'm liking that. Yeah, so that's a bottle. I have another version of this on GrabCAD, which should be a lot of fun. That other version also has some details that can be added to and whatnot. So if you changed it, go ahead and upload some of this to GrabCAD and ping me in a comment, and maybe I can feature it or something. So I almost forgot to do this part. So I pulled up a different bottle that is very similar to the one that we did in the video here. What if we want to do this using surfacing instead of shell? And to be simple, I'm going to just roll back right up until we're about to do the shell. And how would we do this with surfacing? This is a feature that's only available with Alibre Design Pro. So keep that in mind if you're running an Atom. This part is not for you. We'll first head on over to the Surface tab. So instead of shelling it, we head over to the Surface tab and we're going to say delete face. And we're going to delete the face that we want to be open, right? If this bottle had multiple openings, we would click on the face of every opening that we want to be an opening. And we're going to say OK. And now this thing is converted into an infinitely thin surface, right? So this is not a solid. This is not something that is an end product in any way, right? What we're looking at is a means to an end because everything on this is infinitely thin. If I show my section view, I don't even know if it's sectioning it because yeah, I think that'll only section solids. So these are infinitely thin surfaces that are representing the outside of the bottle, but it's pretty easy to know what happens next. We say we want to thicken the surface, and we select the surface that we want to thicken, and we don't want to thicken going out. Instead, we'll thicken going in. You can do it either way, I guess. And 0.1 should be fine. There it is, right? So now, if I go down and choose the surfaces, I can always hide my surface. So it's also important to say that if I go to delete face and I unhide my surface for a second, and then I go to inspect and I go to physical properties and I calculate my volume of my part is 0, my mass is 0, my surface area is 0, because these surfaces are infinitely thin, right? They're only a tool to get to your end product. After I thicken the surface, and then I pull my physical properties, and I can even do so at high accuracy, and I calculate. Now I have a volume, a mass, a surface area, center of mass, and so on. even mass moments of inertia. That's pretty cool. So that's important, right? Surfaces are not an end product. They're just the means to produce what we want to in the end. So that's a way that we can make a bottle if we don't want a shell. What the advantages are, I don't know very much. I think shell is going to be better for almost everything. But surfacing is very handy in certain situations. But I'd recommend doing shell. Either way, how do we take the volume of this bottle? Well, for that, I'm going to start a new part. And in my new part, I'll select my top plane, activate a 2D sketch. We'll go for a center rectangle. We're going to say equal. And then I'll give this a distance of 16, right? And then we'll extrude it. Oh, and I also have to make sure that this line is horizontal. And then I'll deactivate and extrude it to 16. So we have a 16 by 16 by 16 cube. We're going to say Boolean subtract. And I'm inserting the bottle that I've just made. Or at least a bottle that will work, right? So we've got our hollow bottle. And let's say that we fill the fluid up to the level of this face. Obviously this is an external face, but we'll say that the internal fluid is at the level of this external face. We'll constrain it just like that. So as you can probably imagine, we're going to use this to represent the fluid inside. Now, I'm still free to go in the X and Y directions, but as long as I'm not poking out of the block anywhere, then I'm good to go. So we're going to hit the green check, and we're subtracting the bottle from the cube. And now this cube is actually in two different solid bodies, right? We have kind of this internal body and this external body. And obviously, if I take the volume of this, it's not going to be the volume of the fluid. So, because we just took the volume of a surface and found that the volume of a surface is 0, why don't we just come over here to surfaces? We'll delete face. And then I can do as I've done before, find my surfaces down here. And we're going to hide and hide. And there we have the fluid that is sitting inside of the bottle. You can tell there's our air trap that was going to be under the handle when it was filled up. So we should have a pretty good estimate of what the fluid is going to be like at this level. And all I have to do is go to inspect, physical properties. We'll go to very high accuracy. So 661.2539 cubic inches. I'm going to say that's 2.75 gallons-ish. Let's take a look here. So I've got 1 cubic inch here. We're going to say 661.2539. 2.86. I was pretty darn close. I'm a genius. So this is just under 3 gallons. And of course, adjust away if you want to make it an exact volume of some kind. So that's how we use the surfacing method. That's how we find the volume. I hope this was helpful. If it was, please subscribe. I'll see you in the next one.